Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Leftovers by Matt Tressel. And here are the rules. Normal Sudoku rules apply and all clues are standard. Normal Sudoku rules means that you must place the digits 1 through 9 once each in every row, column, and 3 by 3 box. Arrows. Digits along an arrow line sum to the digit in the attached circle. So, for example, this circle is equal to the sum of these 3 digits. This circle is equal to the sum of these 3 digits. This circle is equal to the sum of these 3 digits, and it's also equal to the sum of those 3 digits. This circle is equal to the sum of those 3 digits. In an example, this could be 1, 6, 1, and this would be 8. And that would work because this circle is equal to the sum of the digits on the arrow. And that's how arrows work. Killer cages. Digits in a cage sum to the value indicated in the top left corner, if given. Digits may not repeat in a cage. Remember that. Digits may not repeat in a cage. So, for example, these 3 digits must add up to 15, these 2 digits must add up to 15, these 3 digits must add up to 15, and these 2 digits must add up to 15. These digits cannot have repeats, remember. And that's how killer cages work. Oh, an example of this would be, I don't know, let's do this one, 1, 5, and 9. Those 3 digits add up to 15, therefore that fulfills the killer cage rule. Partial crop key. I'm not sure why it's called partial crop key. These are just white crop key dots. Digits separated by a white dot are consecutive. So, for example, if this were a 6, this would have to be a 5 or a 7 to be consecutive with the 6. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first that I thought of was these 2 digits have to be either 6, 9 or it's 7, 8, right? Well, whatever those 2 digits are, so let's make it red. They cannot be in these 5 digits along in this cage. And we know this cage has all 9 digits because, again, there are no repeats in killer cages. So that's why I kept emphasizing that in the rules. Therefore, these cannot be the 6 and 9, and you have to have the red ones in one of those 4 cells. So, whatever this cell is cannot be the ones that are here. It has to be the opposite ones, right? So, or not the opposite ones. If this is 6, 9, this has to be the 7, 8 ones. If this is 7, 8, this has to be the 6, 9, because they obviously the 6 and the 9, the 7 and 8 would have to be here if that's the case. So whatever's in these cells must then be in these 4 cells. Well, we know the red cells are there, right? And the pink cells have to be here, which means this cannot be red or pink. Similarly, if this is red, this is pink. The red and the pink cells both cannot be here or here. So this has to be at most 4 or 5, right? Because it cannot be 6, 7, 8, 9. This can't be 6, 7, 8, 9. We know this is 4 or 5 at most. And the thing is, it has to be at least 4. Because if it's not, well, this doesn't work then, right? This is 1, 2 at most. This is 1 at most. Sorry, 1 at 2 at least. This is 1 at least. So therefore, it has to be at least 4. So therefore, we have 1 degree of freedom along this arrow. So it could be this one going up to 2. Or this is 1 and 2, and this goes up to 3. So this can never be 3. If this were 3, this would have to be 1 and 2 at least, but that doesn't work. Similarly, this is 1 or 2. This is 1, 2, or 3. This is 1 or 2. But where are these digits in those cages, right? So we're going to make them orange and yellow. Well, in this cage, again, the orange cannot be any of these 5. So it has to be one of these 4. So this one has to be different than this 5, right? Or what? Sorry, this orange has to be different from the yellow, right? Because the orange has to be here, which means this can never be orange. So therefore, the yellow, similarly, cannot be in these 5 cells, so it has to be in one of these 4 cells. Therefore, they cannot be the same. Therefore, one of these is a 4 and one of these is a 5, which means this cannot be 4 or 5 either, right? Because it can't be orange and it can't be yellow. Therefore, this is 1, 2, or 3. Now, if that's the case, that makes things interesting. So first of all, one of these has to be 1, 2, and 1, right? So this would be 1, this would be 2, and then this would be 1, right? The other one has to be, could be 1, 2, 1, 2, or it could be 1, 1, 3, 1, or something along those lines, right? So we know that, well, first of all, this has to contain a 1, right? Even if this were 1, this is either 1, 2, or it's 1, 3, right? Similarly, this has to contain a 1, right? So this cannot be 1. It cannot be 1. It cannot be 2 either. Because we know one of these is 1, 2, and then 1, right? We also know this can't be a 1. This is so this has to be at least 3. We know it's 1, 2, and a 1 somewhere, right? So this is 1, 2, 1, which would mean this is 3 at most. This is 3 at least. This is 2 at least. This has to be 1 at least, which means this is at least 6 here. So this is 6, 7, 8, 9. So these add up to, this is 4. One of these is 4. One of these is 5. We're not sure which. In addition, this is at least 4 digits, which could be 2 through 5 at least, which have to be 2 through 5 at least. So that's 14 at least in both of these cells. So that would mean this is greater than, this has to include 2 1s at least, so this is either 8 or 9, right? This has to be at least 6 through 9, because we know this has to be at least 1, 2, or 3, so this is 1, 2, 3, 4, 5, 6 at least. One of these is 1, 2, and 1. The other one we don't know, right? But 1, so it's either 1, 2, 1 here, or this is 1, 2, 1. Either way, this can never be 2, and this can never be 1, right? Because we know this is at least 1. And one of them has to be 1. The other one could be 2, 1, 2, but we're not sure. This cannot be 6, because this is at least 2 and 3, so this has to be 4 at most. This is at least 3. So it could add up to 8 here, which would mean this would have to be up to 6. This adds up to 8 at most 2, so it's at least 5. So we know either this is 1 or this is 1. Actually, we know there has to be a 1 here, and there has to be a 1 here in both senses, right? This has to be 1. Right, because it's either 1, 3, 1, or it's 2, 1, 2 here. If it's the 5, or it's 1, 2, 1, in which case both of these are 1. So either way, 15 does not have a 1. Let's see. This cannot be 3, because if this were 3, this would have to be 1 and 2 added together, which would eliminate all possibilities for that cell. So this is at least 4. So we have 4, 5, 6, 7, 8, and 9. This cannot be 1. So this would be at most 2. This could be a 1, because we only know one of these or one of these. We're not sure about specifically this one. But the problem is it has to be up to 9, right? So this could be 1 through 7. This is 2 through 8. This is 8 or 9. So this cannot be 1 and 8 because that would force that to be 9, and that's not possible here. So this has to be 1 through 6. This is 1 through 6. So again, this cannot be 8, because if this were 8, this would have to be 1, and that would be 9, which would eliminate all possibilities for that cell. This cell obviously cannot contain a 9 either, because if this is 9, it would have to be with 8 to be consecutive, and that's not possible. So this has to be... It also cannot be, interestingly enough, it cannot be 2 and 1, right? So if it's 2 and 1, that will be the minimum here, 3, 4, and 5. It cannot be 2 and 3 either, right? Because if it's 2 and 3, what's the minimum here? It's 1, 4, 5, which adds up to 10. So the only ones it starts with, it could be 3, 4, it could be 4, 5, it could be 5, 6, it could be 6, 7, it could be 7, 8. And those are the only possibilities. So this cannot contain a 1 for this 15. So it's either 2, 4, 9, 2, 5, 8, 2, 6, 7, 3, 4, 8, 3, 5, 7, or 4, 5, 6. Any of those work for this 15. Similarly here. We know this can't be 4 or 5 because it sees both the yellow 4, 5 and the orange 4, 5, and we know they're different. So this cannot be 4 or 5. So this is 3 or 6. Hmm. Oh, this can't be 6 because we know the 6, 7, 8, 9. Either the 6, 9's here and this is 7, 8, or the 7, 8's here and this is 6, 9. Oh, also cannot be 4, 5. Right? Because we know the orange 4, 5 is here and the yellow 4, 5 is here. So these have to be 1, 2, or 3. Which means this cannot, similarly, this has to be 1, 2, or 3. So we have a 1, 2, 3 triplet now in box 9, which eliminates 1, 2, and 3 from the rest of the box. So this cannot be 1, 2, or 3. This cannot be 1, 2, or 3. Therefore, if there's a 4, 5, there has to be a 4, 5, or 6. And we know it has to be here or here, right? It cannot be, so this is now 4, 5, 6, 7, 8, 9. It cannot be in both of them. Because, okay, so, right. If this is a 4, a 5, or a 6, the other two digits have to be from 1 through 3, right? If you have a 4, which is the lowest amount, then you would have to have a 2 and a 3 to be with it to add up to 9, right? Or you could have a 1 and 3, but you cannot have another 4 or 5 or 6. Because if you did have 2, 4, 5, or 6s in these cells, that would add up to 9 already, at minimum. And then you would have to have a 10 along there. So that's not possible. So this can't be 4, 5, or 6. This can't be 4, 5, or 6. We know this is 1, 2, or 3. Okay. Hmm. Huh. Hmm. Mm. Okay. What else does that tell us? Not sure. Mm. Oh, interesting. What happens if this is a 3? So if this is a 3, this becomes 1, 2, 1, 2, and this is 1, 2, 1, 2. So they both must add up to 3 here, which means one of these would have to be 1 to add up to 4, and the other one would have to be 2 to add up to 5. So this could not be 2 or 3 in that instance. Therefore, in that instance, it would have to be either 4 or 5 in that case, which means this is at maximum a 2 to be 4, 3, and 2, right? To make that 9. So if that's the case, if this is 3, okay, so that's another case then. If this is 3, this is at least 4, because it cannot be 2 or 1, and it can't be 3, so it must be at least 4. So this actually is 4, 3, and 1 at minimum. So therefore this would be 8. If this is 6, this has to be 2 and 1, and that has to be 9. So either way, this has to be an 8 or a 9 here. This cannot be 3, because if this were 3, this would be 6, and that would already add up to 9. So this can't be 3. It could be 4 or 5 here, and this is 3 or 6. So this is at most, sorry, this has to be at least 7, which means this cannot be 3 or 4. It has to be at most 1 or 2. Um, What else do we know about this? This still could be 6 with 2 and 1. And okay, so if this is a 3 also, again, this so one of them would have to be 1, 2, 1. The other one would have to be 2, 1, 2. Right? So 1 and 2 both couldn't, so we'd have, right, so say this one was the 1, right? So this would be 1, 2, 1, and this would have to be 2, 1, 2, if that's the case. So 1 cannot be here, and 1 cannot be here. So this cannot be 2, and this could not be 1. Obviously, this couldn't be 6. So this would have to be... Hmm. Oh, this is interesting. If this is 6, this has to be 2, this has to be 1. Which means this is 1, this is 1. Therefore, this can no longer be 1. It cannot be 2 and 3, so therefore this would have to be 1. This is similar, cannot be 1. Therefore, it cannot be 2 and 3, so this must be 1. And you have a 2 or 3 here and a 2 or 3 here, but they're opposite ones. And this can't be 1, can't be 3. So this is 4, 5, or 6, which means this has to be less than 5 or 6. less than 4, this is 2 or 3, if that's the case. Right? So this is at least 7, because it could be, has to be 2 and 4 at minimum. Oh, that's interesting. I didn't think about that, but yeah. So this is, I don't know if this goes down a good path, but we know that's the case. What can this be for these 2 digits? I think it always has to have a 1, 2, or a 3, right? And it cannot have 2 out of those, so therefore this can't be 4. It could potentially have 1, 4, but that would make that 5. So one of these cannot be 4 and 5, right? And that's the only way you cannot have a 1, 2, or 3 in one of these 2 cells. If this is specifically 4, 5, and this adds up to 9. But we already have, if this is 4, 5, that would eliminate this as a possibility. So we know one of these then has to be 1, 2, or 3, which eliminates, with these other 2, which must be 1, 2, or 3, eliminates the possibility for any other cell in the column to be 1, 2, or 3. Therefore, this is also 4, 5, 4 through 9. Um, so this cannot be 5, because if this were 5, it would have to be, it cannot be 2, 3, because that would eliminate 2 possibilities for both of these cells, which would require both of them now to be 1, which breaks the arrow rule set or the Sudoku rule set, depending on which one. So this cannot be 5. Yeah, or if this is 5, this would have to be 1, 4 then, if we tried that. But the problem is then that would eliminate 4 and 5 from the rest of the box, which eliminates all the possibilities for that cell. So this cannot be 5. Um, hmm. Ugh. What else do we know? Say this was a 3 here. If this is a 3, that means this is 1 and 1. So this is 5, which makes this 4. So this has to be 1, 2, and 1. So then this becomes 6. This is a 2. This has to be 1. There is no 3 here. This can't be 1. So this obviously can't be 4, 5, 6. This can't be 6. So far this is okay. Hmm. So whatever digit is here, it sees all of these digits. So we're gonna make this A, I guess. If this is A, one of the A's has to be in one of these 3 cells. Similarly, this is B. It sees all of these cells, so it must be one of these cells. Right? And this is the C, right? But we don't know anything more about that. Mm. That means A has to be one of these three cells, and B has to be one of those three cells. Let's see. So this has to be the red one, right? One of the red ones. We're not sure which. So whichever one this is, it must be either that one or this one, right? Hmm. Hmm. One thing is, for this to be 6, this one specifically has to be 2, and 4. Because if this is 1, 5, the problem is this becomes 4 with 2, and then these add up to 3 at least. So that wouldn't work. So if this is 6, this would have to be 2, 4, which would mean this would be 5, this would be 1. So this would have to be 1, because this could not be 1, and this would be 3. So then this would be 7, 8. This would have to be 4, which would force this to be 1, 2, and 1. This can't be 3, so this is 6, which makes that a 2. So this is a 1. Again, this can't be 1 or 3. This can't be 4, 5, or 6. This is a 2, so this can't be 2. And this can't be 2. So this can never be 4. And it can't be 6, so it must be 5. 1, 3. Therefore, this is 9. Which means this has to be 6 and 9. But this can't be 6. So this cannot be 4, 6, or 9. It's 5, 7, 8. This can't be 5, 7, 8. So it's 4, 6, or 9. This cannot be 4, 5, 6, or 9. So this is 7, 8, 7, 8. Which means this has to be 7, 8, and 7, 8. This can't be 5. This has to be 1 or 3. This is 1 or 3. These are 1, 2, and 3. Hmm. This can't be 9. So this is 4 or 6. So this would have to be 3 or 9. This would have to be 3 digits with so it would be either 2, 4, 9, 2, 5, 8, or 2, 6, 7. Well, it can't be 2, 6, 7. So 2, 5, 8, 2, 4, 9, or it cannot be 4, 5, 6. So this can't be 2, this would be 4, this would be a 2. So far this works okay. So this would be 2 with either 4, 9, or it's 5, 8. And you cannot have 2, 6, 7, and you can't have 4, 5, 6, and you can't have a 1 or a 3. So this would be 8 or 9. This is 8, or well, this would be 9. So this can't be 9. This would be 3. This would be 9. This can no longer be 9 then. So it has to be 2, 5, and 8, which forces this to be 7 and this to be 8. This can't be 9 anymore, so this is 6, this is 9. One of these is 5. So this could not be 5, which means it could be 3, 4. It could be... it cannot have a 5, so this is 2 with either 1 and 6, or it's 3 and 4. So this could still be 3 or 4. This could be 6, 7. This could be 8. So this can no longer be 6 because that would require 1, 2, and 6 to add up to 9. So far, this seems okay. I don't know. Where is the 4 and the 6 here, if that's the case? Either this is 4 or 6, or this is 4 or 6. Therefore, one of these has to be 4 or 6. So it must be either 3, 4, or this is 6, 7. So this can never be 8, which means 8 would have to be here. This cannot have a 9 or 6. It cannot be 1 or 2. So it could be 3, 4, 8, or 3, 5, 7. Because it cannot be 4, 5, 6. 3, 4, 8, or 3, 5, 7. And those both work. So either way, this is a 3. This we're not sure. It could be 1, 2, 6, or 2, 3, 4. Okay, so then in that case, this could not be 3. Right? Because if this were a 3, that would force this to be 6, 7. But the problem is then this would have to be 2, 3, and 4, which would eliminate the 3 again. So none of these could be 3. This can't be 3. Therefore, this must be a 3. Four has to be one of these two, and then we have a 9 there too. 4, 9. This is 6 or 7. This is 6 or 7, which makes this have to be what? 8 and 7. 7 and 8 is only consecutive with 6 or 9. This is 7 or 8. This is 7 or 8, so this cannot have a 7 or 8, and this cannot have a 7 or 8. This can't be 1 either. This is now 1 and 4 just. Oh, what about this? This is 3 and 5. This is 3 or 5, so it cannot be 3, which makes that 5, which makes that 3. This cannot be 5, 7, so it's now 3, 4, 8, which forces that to be 7, makes that 8, which makes that 9. So this is all actually works fine. Except where's the 1 here? So that doesn't work. Interesting. Yes. That makes sense. Okay, I see the problem. Okay. The issue is, what happens if this is 3 and this is 2, right? So then one of these is 1 and one of these is a 4, one of these is a 5. And the 5 had a 3 with it. Well, then this would be 1, which would make that a 1. These would be 1. These would both be 1. Where's the 1 in box? Well, where's the 1 in row 1? It has to be one of those two cells. But where's the 1 in column 1 in that case? It has to be both of those cells, which means if this is 1 something 1 and this is 1 something 1, they would both basically break, because the 1 for this cell would have to, for column 1, would have to be in one of these two cells, and the 1 for the row 1 would have to be one of these two cells, which means that there's 2 1s in box 1, which would break normal Sudoku rules. So if this is one, if the 4 always has to be 1, 2, and 1 in that order. So we know there's a 1 here and a 1 here, and that, which makes the 1 one of those, which means 1 cannot be one of these two cells. So in the opposite, it could not be 1, 3, 1. It would have to be 2, 1, and 2. That's interesting, right? So we know these are not the same. They cannot be the same. They are both 1 and 2. So this cannot be 2, which means this can't be a 6. So therefore, we know, because if it's 6, that would be at minimum 10 along the arrow, so that doesn't work. So this is a 3, which means this can't be 3, and this can't be 3. So we have, okay, so this can't be 6 again. Well, this can't be 2, because it can't be 1 or 2 here. And then if it's 3, it can't be 3 here, obviously. So therefore, this can't be 6 again, because these two digits by themselves would add up to 10, which is not a digit. So this must be 3, which means this can't be 3, and this can't be 3. So now we know we have a 1, 2, 1, 2 pair in row 2, row 3, and column 3. So the rest of row 3 cannot be 1, 2, or 3, and the rest of column 3 cannot be 1, 2, or 3. Therefore, this cannot be 2 or 3. It has to be 4, 5, 6, or 7. And we know this, again, has to contain one of 1, 2, or 3, at least. So this is a 1, 2, or 3. This is 4, 5, 6, or 7. This cannot be 1, 2, so it has to be 4, 5, 3, 4, 5, 6, 7, 8, 9. Okay, if that's the case, then we know there's either a 1 here or a 1 here, right? There cannot be a 1 in either of these two spots. However, we don't know about... Similarly, there has to be a 2, but on the other side. So 1 has to be one of these spots, and then the 2 also has to be one of these two spots, which means this can't be 1, 2, or 3. So this is also 4, 5, 6. Oh, well, we already knew that. This is 4 through 9. This is 4 through 9. These are 4 through 9, and these are 4 through 9, because of the 1, 2, 1, 2 pair we have. Therefore, we have a 4, 5, 6, 7, 8, 9 sextuplet in box 1, which eliminates 4, 5, 6, 7, 8, 9 from the rest of the boxes. Therefore, we know this is 1 and 2. Aha! And now we have a 1, 2, 1, 2 pair in row 3, which eliminates row 2, which eliminates 1 and 2 from the rest of the row, which means this has to be a 3. So this cannot be 3, and this cannot be 3. So whatever this is 1 or 2. This is 1 and 2, 1 and 2, with either 5 or 6 to add up to 8 or 9, right? Because this has to be 1, 2, 1, 2. This cannot be 7, obviously, so therefore this... And again, this is why we knew this could not be 6, because you have 3 and 4 at minimum. We tried actually doing that, and we showed that that couldn't be the case. So this 15 cannot contain 1 and 2, right? Because we have a 1, 2, 1, 2 pair here. no matter what. It's either 1, 2, and 1, or 2, 1, and 2. Either way, so therefore this is 3, 4, 8, 3, 5, 7, or 4, 5, 6. And we know, okay, in this one specifically, this must equal 3, actually. So that cannot be 4, 5, 6. It's 3, 4, and 8, or 3, 5, 7. Aha! And we get to another thing. Well, what is this digit, right? It cannot have... Where are the 1 and 2s in row 1? It cannot be here because we have a 1, 2, 1, 2 pair here. Cannot be here because this is a 1, 2, 1, 2 pair. Can't be either of these because of the way the arrow works and the 15 cage works. Therefore, this must be a 1 or 2. So this cannot be B, and it cannot be 1 or 2. It can't be a 9, because if this is 7, 8, that forces that to be 9. Therefore, this must be 4 through 8. We're not sure which, though. This, however, does not have to have a 3. So this could be... well, in addition to that... okay. We know there's a 7 or 8 here. We know there's an 8 or 9 here, and this is 7, 8, or 9. So we have 3 cells in row 1 which must contain a 7, an 8, or a 9, which eliminates 7, 8, or 9 from the rest of the cells in that row, which means this has to be 6, which makes this a 9, and therefore this can't be 9. So, and this can't be 6 or 9, so we know this cannot be 6 and 9, this has to be 7, 8 then, which means this can't be 7, 8. So this has to be some combination of 4, 5, 7, 8, right? So this can't be 6 anymore. This is 4, 5. This is 4, 5 to add up to 7 or 8. This can't be 4, 5 because of the 4, 5, 4, 5 pair in box 3. And it can't be 6 because of the 6. These can't be 4, 5 because of the 4, 5, 4, 5 pair. We know, therefore, this has to be 7 or 8. This is 7 or 8. We have 2 cells in row 1, which must be 7 or 8, which eliminates 7 or 8 from the rest of the row, which means this can't be 8. This has to be a 9. Okay. This cannot be 9, but it couldn't anyways. So these can't be 9 anyways. One of these has to be a 9. This is 6, 7, or 8, which can only be consecutive with 5 through 9. But this cannot be 7, 8, 7, 8. But that doesn't necessarily limit things. Anyways, these can't be 9 anymore. This can't be 6, 7, or 8 because of the 7, 8 pair in row 1 in the 6. Therefore, we have a 4, 5, 4, 5 pair in box 1, which eliminates 4 and 5 from the rest of the box. So this cannot be 4, 5. We also have a 4, 5, 4, 5 pair in column 3, which eliminates 4 and 5 from the rest of the column. So this can't be 4, 5. This can't be 4, 5. This cannot be 7 or 8, because if this were 7 or 8, well, we have a 7, 8, 7, 8 pair in box 7, which eliminates that possibility. Okay. So this has to be 6 or 9. We know... Well, we don't know about this. It still could be 8. This is 4, 5. So this is the orange 4, 5. So the orange cannot be here or here. It must be one of these 2 cells, and we're not sure which. This must be the yellow 4, 5. And this is the orange 4, 5. if this is 4, this must be 1, and this must be 2, and therefore this must be 1, which would force that to be 2. So if this is 4, this is 1, 2, 1, which means that these two would have to add up to 6, if that's the case. Because this would be, so this would be the same as this one. And these must be different then, right? Which means it has to be that one, which means this cannot be. So first of all, this can't be 2, because we know these are opposite ones. So this is orange, which makes this yellow, which makes this orange. This has to be yellow then. This one cannot be orange, so it must be yellow, which forces this to be orange. Which means the orange one has to be here also. We don't know about for the, yeah, these numbers. This cannot be 1 because they're opposite ones too. So the orange 1, 2 cannot be here. It has to be one of these two. The orange 1, 2 cannot be here or here. So it's one of these 4. The yellow 1, 2 has to be one of these two. I'm not sure which, though. Ah, since this is the orange one. Okay, yeah, that's why I colored it this way. So if this is 4, this would become 1, 2, 1, which means these two add up to 6. If this is 5, this becomes 2, 1, 2. So either way, the oranges always add up to 6. We know this is an orange, and this must add up to 6. So this cannot be the yellow. It has to be the orange 1, 2, which means the yellow 1, 2 then has to be here. These can either be the yellow 1, 2s. I guess this one could be yellow 1, 2. Ah, but this can't be 1 or 2 because of the way that the white crop key dot works, and that we have to have 2 digits that are from 1, 2, and 3. So it cannot be 1, 2 here. Can't be 2, 3, obviously, so there cannot be a 1 or yellow 1 or 2 here. Therefore, this must be specifically the yellow 1, 2. And this, therefore, is the A. So this is A. Which means, this then has to be the yellow 1, 2, because this cannot be. So therefore, this has to be 3. Which makes this the yellow 1, 2, right? Oops, not red. Yellow. So this cannot be 3. This is a 3. Either way, if this is 8, this would be 1, 2, 1, 2, 5. This can no longer be 5. It cannot be 6. It would have to be 4 and 3 here. If this is 9, this would have to be 1, 2, 1, 2, 6. And this would either be 4 or 5, which would mean a 3 would have to be here. So either way, a 3 has to be here. Which means this cannot be 3. This cannot be 3. This cannot be 3. Which means one of these two is a 3. We're not sure which. Also, this is, yeah, this, we know the A cannot be there. So because this is the A, essentially. So this yellow 1, 2 is the A. So this matches that. Well, anyways. We don't need the A designation anymore. We can also delete those because we don't need that. This is not B. This is the B designation. We don't know where the yellow 4-5 is. It has to be one of these 3 cells, but we're not sure which. So this is the orange 4-5 here. So the yellow 4-5 is one of these 2 cells. This cannot be 6 anymore. So this has to be a 4-5. We're not sure which one it is, though. It could be orange, it could be yellow. This is 4, 5, or 6, which means this is at minimum 8. So this is also 8 and 9. So this is an 8, 9, 8, 9 pair here. This can't be 6 or 5 because of the way it's set up. Because if this were 5, this would be 4 and 5 at least, which is 9, and plus 1 would be 10. So this is 8 or 9. This is 8. This can never be 6. So this is also a 4 or 5 here. Interesting. So this can't be 4 then. This has to be a 3. So this is 3, which means this can't be 3, which forces this to be the 3. Right. So we don't know what this is, interestingly enough. If it's the orange one, that means this has to be 9, which forces this to be 8. So again, you cannot have 8 or 9 here, right? Oh. Well, where is the 7 in box 9? It has to be here, specifically. Can't be here, because it can't. 7 can never add up with 2 digits to add up to another digit. As long as it's unique, cannot be here because of the 7-8 pair. Therefore, this is a 7, which means this is a red. The other red is here, and the orange 4-5. Oh, we also know the blue, or sorry, the orange 1-2 is here too. Huh. Interesting. And this cannot be orange 1-2. This cannot be orange 1-2. Therefore, this is the orange 1-2. So this is not the B. This is not the B. This has to be 8 with a 4 or 5. We're not sure which, though. This is obviously, one of these is the orange 4-5, but we're not sure which. This can no longer be 8 here, because we know one of these is an 8. One of these is 4, 5, or 6, and one of these is 7, 9. We're not sure which. So, where is the 7 in row 9? Cannot be any of these 3 cells, can't be any of these 3 cells, so it must be one of these 2. So it cannot be 4 or 5, it's 7 here with 6 or 8. We're not sure which. Either way, we have now a 6, 7, 8, 9 quadruplet in row 9, which eliminates 6 through 9 from the rest of the cells. So this must be 1, 2, and 4, 5. Well, this can't be 1 or 2 because we have a 1, 2, 1, 2 pair here. So this must be 4 or 5, which means this is the yellow 4, 5 because we see a 4, 5 here. So this can't be 5. This can't be 5. This can't be 4 or 5. Therefore, this is a 1 or 2 and is the orange 1 or 2, which means this is the orange 4, 5. The yellow 4, 5 is here. And We don't know still. We have all the 1, 2s, I think, set, right? We don't have the orange 1, 2 here, and we do have the yellow 1, 2. So where's the last orange 1, 2? It has to be here. Because we see here and here, this sees that, this sees that. So therefore, it must be here specifically. So this is orange 1, 2. One of these is 3, obviously. This cannot be... Well, it could be 3, 4, 8, or 3, 5. We don't know. This could be 3, this could be 3. So what is this? Not sure. This is yellow, this is orange. So this does not add up to 6. It must add up to 5 then. Right? Because since it can't add up to 6, this can no longer be 9. That means this has to be 8, which makes that a 9. So these two do have to add up to 6. So therefore, this is an orange 4, 5, which means this cannot be orange 4, 5. So this has to be 7, 8, which means this can't be 7, 8. This is the orange 4, 5. So this is 9. This is 8. Therefore, this must be 5. The orange 4, 5s are now, we now know, are 4. So these must be 4. This is 4 and 5. This has to be 6. So this is not yellow. It's the pink. This is the other pink. So this has to be 5 and 9. The orange 1s and 2s have to be 2. So this is 2. This is 2. This is 2. This must be a 2. This is a 2. This is 1. All the yellow 1s. So this is a 2. All the yellow 1, 2s have to be a 1. So these are all 1s. All the yellow 4, 5s have to be a 5. I don't know why we have these. So these are all 5, which works. This has to be a 8 to add up to 15. So therefore this is 7, which works. That's an 8. This can no longer be 4, 5, or 7. So this is a 6, 9 pair. This can't be 5, so it's a 4, 8, 4, 8 pair. And this can't be 4, so this must be the 8, which makes this a 4. And now we're probably just going to be doing a lot of Sudoku. So this can't be 8, this is 6 or 7, which means this can't be 6, so therefore this is 9. These can no longer be 9. This can't be 8 either. What does that leave here? This is a 3 or a 6. We know there's a 4 and a 5 here. This has to be 4. One of these is a 5. So 4 and 5 to add up to 15 would have to be with 6. So this can't be 6, which makes that a 3. There's a 6. This can't be 6. So this is 7 or 8. Neither of these can be 6. This cannot be 7, 8, 7, 8. Because we have a 7, 8, 7, 8 pair here. Therefore, 7 and 8 are eliminated from the rest of the cells, which makes this a 9. Therefore, this must be 8. This must be 7. This must be 8. This must be 7. This can no longer be 7 or 8. This is 6 or 9. This can't be 7. This must be 6. It must be 6. So this can't be 6. This is 4, 5, and 6. We're not sure where this is. But this 9 means this can't be 9. So this is 6, which makes that 9. This can't be 6. So this is 5, which makes that a 6. And this must be a 3. And as I said, we're just probably doing Sudoku now. This has to be 5 and 7. We're not sure which one's which. This is 5 or 7. This is 5 or 7. We have remaining here, what are these cells? This has to be 3, 5, and 7. This can't be 3. This can't be 5. This has to be 3, 7, or 8, but it can't be 8, so this must be 3, 7, which forms a 3, 7, 3, 7 pair in row 4, so this can't be 7. Therefore, this is an 8, which makes that a 7. This can't be 7. This can't be 3 because of this 3, so therefore this must be 7, which makes this 3. This is a 5. This is a 7. This can no longer be 7, so this is 5, which makes that 7. That makes this a 9, which makes that 5. We have here a 6, 8 pair, but this can't be 8, so therefore this is 6, which makes that 8. And this is, so this, what is this? This is 5 and 9, but this can't be 5, so therefore that's a 9, which makes that 5. This can't, 9 means this can't be 9, so this is a 6, that's a 9, which makes that a 7, that's a 6. And we're left with 4 and 8, so therefore this is 4, and that's an 8. And that was actually pretty cool. I like it because of the coloring, probably. But, like, the whole idea of what this could be, right? What this arrow had to be was pretty cool because it, like, you had to figure out, hey, this can't be 1, this can't be 1 or 2. One of them can only be in each of these spots, so therefore one of them has to be 2, 1, 2, and the other one has to be 1, 2, 1 to fit the solution. And everything sort of just flowed from there, which was very cool. Anyways, I hope you had a cool time of watching this or solving it, and I hope you see you next time on Frank Puzzles. Take care.